Hello everyone. Welcome to our channel. Today, the concept of irrational numbers is well defined. That is, irrational numbers cannot be written as a ratio of two integers. Their decimal expansions go on forever without repeating, unlike rational numbers which terminate, or repeat the digits. Examples include pi, phi, and square root 2. In general, the square root, or any root, of a number that is not a perfect square or perfect power is irrational. As we talked in last video, the mathematicians realized the concept of rational numbers very early, around 300 BC, however, its formal discovery is intertwined with the discovery of irrational numbers. Thus, it is time for us to explore the history of irrational numbers. Around 6th century BC, the Pythagoreans discovered irrational numbers while studying geometry. For example, the diagonal of a square with side 1 has length, the square root of 2, which cannot be expressed as a fraction. Legend says that the Pythagoreans kept this discovery secret, because it challenged their belief that all numbers are ratios of integers. Around the 5th century BC, Greek mathematician, Hippasus of Metapontum, is credited with the first proof of irrational numbers, likely by demonstrating that the diagonal of a unit square and its side could not be expressed as a ratio of two integers. His proof was significant because it contradicted the Pythagorean belief that all numbers could be expressed as a ratio of whole numbers. Around 300 BC, Euclid systematically studied irrational numbers. He classified in his famous book, Elements, incommensurable magnitudes, which are essentially irrational numbers. They represented quantities that could not be expressed as ratios of integers. The Indian mathematicians such as Sulbasutras, between 800 and 500 BC, mentioned the existence of square roots of numbers like 2, which is now recognized as an irrational number. They approximated irrationals, the square root of 2, using continued fractions. Arabic mathematicians translated Greek works and further studied irrationals in algebraic and geometric contexts. However, a more systematic study and proof of their irrationality occurred in later centuries, particularly with the work of mathematicians like Leonhard Euler and Johann Lambert. With the development of real numbers, irrational numbers were better understood. Decimal expansions helped distinguish rational from irrational numbers. By the 19th century, mathematicians like Dedekind and Cantor rigorously defined irrationals as part of the real numbers, completing the number line. In summary, rational numbers are fractions, ratios of integers, used since ancient times. Irrational numbers are non-fractions, discovered by the Greeks, and rigorously defined in modern mathematics. Together, both rational and irrational numbers form the real number system, fundamental to arithmetic, algebra, geometry, and calculus. Here it would be interesting to point out several open questions. Until today, various combinations of and pi are not known to be irrational numbers. However, Shanuel's conjecture would imply that all of these combined numbers are irrational and even transcendental. The question about the irrationality of Euler's constant gamma is a long-standing open problem in number theory. It is time to come to end our topic. Next, following the timeline in the history of math, we will talk the history of imaginary numbers. Okay, don't forget to like and subscribe. See you next time.